Good evening. This is Donna Blomquist, librarian at the LaSalle Public Library. Welcome to tonight's virtual program, Exploration of Severe Weather. Before we begin, just a few reminders. On May 27th at 7 p.m. Central Time, the library will be joining other libraries across the state in virtually hosting ice skating superfan Jonathan Van Ness and Olympic gold medalist Christy Yamaguchi in a conversation covering figure skating, fabulous style, and more. And on May 23rd at 6 p.m. Central, the library will virtually host public historian Megan Hansen, who will present Department Stores, a Feminine Oasis. Overcoming the cliche, all women love shopping, this presentation takes a look at the department stores built on streets between the White House and the Capitol that served as a place of power and social importance for women in the male-dominated world of Washington, D.C. Megan will take us through the busy streets of DC to look back at how a simple trip to the department store was in fact so much more. As always, all library programming is free and open to the public. It is also shareable, so please feel free to pass the information on to others. This includes watch parties. Any of the library's programs can be watched by groups, and we ask that you let us know how many people watch the program by adding the information to the pop-up survey at the end of the program. And now we welcome Nick Bartholomew with Illinois Storm Chasers, who will help us explore the science of severe weather. Welcome, Nick.
Thank you very much, and thank you for having me. So let me share my screen real quick, and then we will get rocking and rolling. Share sound. All right. So again, good evening, everybody. Thank you for tuning in. Again, my name is Nick Bartholomew with Illinois Storm Chasers. Thank you for joining me on this presentation tonight. We're going to focus this time on severe weather. I know in my last presentation, we focused on winter weather. Now that the season has changed and we are warming up, now is a great time to focus on that severe weather. So a little bit of an overview. I'm going to go through an introduction myself. Again, what got me into weather and specifically what got me into storm chasing. Then we'll move into a little bit about our local climatology. Okay, after that, we'll get into a few different high impact events that impacted much of northern and central Illinois over the past 10 years. Then we'll get into, of course, a little bit about weather forecasting and storm chasing. And then I have some photos and videos to show you guys at the end, as well as a Q&A session. So throughout the presentation, if you have any questions, feel free to utilize the chat box to go ahead and enter those questions in, and we will make sure to get to those at the end. So again, my name is Nick Bartholomew. I joined Illinois Storm Chasers back in January of 2019. Also owner of a company called SWI, which is doing exactly what I'm doing tonight, doing these public programs, not only across the state of Illinois, but across the country as well. Now, I've been storm chasing since 2015, at least out in the plains. Now, in that time, I've seen 27 tornadoes across the country, ranging from as far west as Wyoming to as far south as about 10 to 15 miles from the US-Mexico border. So it's safe to say I've literally been everywhere through the country chasing. But people always like to ask me, why weather? And specifically, why storm chasing? And for me, there's two main reasons. Number one, the movie Twister, which I'm sure everybody listening has either heard of this movie or seen it themselves. Twister came out back in 1996. I was born back in 1994. So growing up, I was not supposed to watch that movie. And my parents would always tell me, Nicholas, you can't watch it. You're not old enough. Well, at that age, I did what every little kid does when their parents tell them not to do something. Of course, I went ahead and did it. And when most kids were watching, networks like Cartoon Network, Disney Channel, and Nickelodeon, here I was watching the Weather Channel and Twister. That was my childhood. So I found that I had a huge interest in weather, but every time I was impacted, I was terrified, to the point where I would literally curl up in a ball and cry. Now, this lasted until I was about 10 or 11 years old. And I always thought, why? Why did I love seeing it on TV, but when I was impacted, I became so scared? Well, it stems back to 1990. Now, back in 1990, yes, it was a few years before I was born, but the strongest tornado in the month of August in U.S. history struck my hometown, Plainfield and Joliet. So my parents' house was hit, grandparents' house was destroyed, and we had a family friend that was buried underneath the St. Mary's Church for about 8 hours. So I heard these stories growing up. So I now thought that every time the sky got dark, that next big Plainfield tornado was going to happen. Or every time there was some lightning and thunder, the next big tornado was going to happen. So it wasn't until about the age of 10 or 11 that I realized that that wasn't the case, that you can just have a thunderstorm and not have anything to worry about. And then, of course, anybody who's from the Chicagoland area is probably familiar with Tom Skilling on WGN. He was one that I watched religiously growing up to learn as much as I could about weather because if you guys watch him, you know that the normal meteorologist on TV gets maybe 2 to 3 minutes to go through their weather segment before producers are in their ear, like, all right, get off the TV so we can get back to news. Skilling, on the other hand, gets like 7 to 8 minutes to do his weather broadcast because of all of his maps and because of the information he goes through. So I started learning a lot about weather at that point, plus doing my own research. And then I turned into that desire years down the road to now get up close and personal with this weather and see these tornadoes up close. Out of the 27 tornadoes that I've seen, I've been in the outer circulation of 2 of those tornadoes. So quite the shift from when I was little and being terrified to now wanting to chase them and get as close as humanly possible. Now, for those of you who aren't familiar with Illinois Storm Chasers, and if you're not and you have Facebook, feel free to give our page a like. It'd be greatly appreciated. But we are an online weather-based company that provides weather forecasting across the state. To this day, we have now 340,000 people that follow us. We got a nice influx of people after those early season outbreaks at the end of March and early April. Now, we incorporated back in 2015, and we have a close working partnership with the local National Weather Service. In addition to that, we also have a working partnership with a tour company called Tornadic Expeditions, which takes regular people out storm chasing. Okay, we take them for 6, 7, or 10-day tours all across the country to chase tornadoes. Super fun experience. I always tell people if you want to chase but don't know how, you want to chase with someone from ISC, Tornadic Expeditions is the way to go because almost every single one of us at ISC guide tours with this company. Now, moving on to a little bit about our local climatology. Our severe weather season typically runs March through October, okay, with our tornado season typically April through June. So here we are in May in the statistical peak of severe weather season. Our squall line season or derecho season, whatever you want to call those long-lived line of damaging winds that cross multiple states, mainly in the summer months, May through August. But just because those are the quote-unquote peak times for severe weather, we all know that events can and do happen year-round. We've had many high-impact events in the months of November, December, January, and February across the state just over the past 10 years. So I always tell people, no matter the time of year, always be prepared for severe weather because you never quite know when or where it's going to strike. Now, in the state of Illinois, we rank in the top 10 in terms of average tornadoes per year. Now, a little bit deeper into that, we are actually number 6 in the country in terms of average tornadoes per year. Now, prior to last year, we were actually number 4. Now, the state that knocked us out of the top 5 will surprise a lot of you. A lot of people will think about states like Oklahoma, Kansas, maybe Alabama, right? States like that. When in fact, the state that knocked us out of the top 5 is actually Florida. And the reason it's Florida is because when you have hurricanes making landfall, on the outer bands, on those outer bands of the hurricane, you get brief, weak tornadoes that spin up. They're not all that long-lived. They don't cause all that much damage, but they still count. So I always say, for us being in a very tornado-prone state as it is here in Illinois, for a state like Florida to knock us out of the top 5, I'm a little bitter about because at the end of the day, we get the tornadoes whether we like it or not. So we might as well have that top 5 designation to go along with that. But in fact, Florida is the one that knocked us out. Now, we average 54 tornadoes a year here in Illinois. Our neighbors to the north in Wisconsin only average 24. So you can see just how much more prone we are to tornadic activity versus our neighbors to the north. Now, people like to always ask me, why does one storm produce a tornado and the next storm doesn't? Or why does one day produce severe weather while the next day doesn't? And it really boils down to 4 main ingredients. Number 1, it's a source of instability. It's the amount of energy within the atmosphere. The hotter and more humid it is, typically the more instability is present for that thunderstorm to take advantage of and grow. So that's ingredient number one. Number two, you need a source of lift. You need something to encourage that air to go from the surface all the way up through the atmosphere, condense, create your clouds, precipitation, so on and so forth. So that could be in the form of a warm front, that can be a cold front, that can be a low pressure system, a outflow boundary, a lake breeze. Again, anything that encourages that air to go vertically through the atmosphere. Number three, you need a source of source of moisture. You need good quality low level moisture. When you walk outside on a warm summer day and you instantly start sweating, there's your quality low level moisture. Okay. And then the last ingredient, we call it wind shear. Now, all wind shear is a change of wind speed and or direction with height. So I'll give you an example. If you're up in an airplane at 35 or 40,000 feet in the air, you're going to have the winds coming out of the west. Then you come down a little bit. Now it's going to come out of the southwest. You keep coming down, it's out of the south. And then eventually down at the ground level, we have winds out of the southeast. So up in the 40,000 feet range, west, down at the surface, southeast, you can see that you have that turning motion through the atmosphere, that gradual turning going all the way down the column towards the surface. Okay, you need that wind shear to get significant severe weather. You can get a pulse type severe storm, kind of your baseline severe weather with just the first three, but that wind shear is going to give you the ability to get that sustained significant severe weather. Now, when we talk about the different types of thunderstorms that we see, okay, there's three main types on Earth. Number one is your single cell thunderstorm. It's your garden variety pop-up storm that you see on a warm summer day. Okay, if any of you guys have been to Florida or anywhere along the Gulf Coast, and I asked you the question, what happens around 3 or 4 o'clock in the afternoon, a lot of you are going to say it starts raining and storming. Okay, now about 30 minutes after it starts raining and storming down in those tropical areas, sun typically comes back out in the day and you resume your day. That is your single cell thunderstorm. It's your garden variety storm, lasts about 30 minutes, produces your heavy rain and some lightning. Nothing else really to it. Now, then you have your multi-cell cluster, which your multi-cell, main difference is single meaning one, multi meaning multiple. Just multiple cells within a larger cluster. Again, these typically don't produce much in the way of severe weather, but they last a little bit longer. So now instead of lasting, 30 minutes, a multi-cell cluster might last 45 minutes to an hour or maybe even a little longer. Okay, still just producing your heavy rain, lightning, and maybe some strong winds. Now, the least common and my absolute favorite, the ones that I drive thousands and thousands of miles every year to see, are going to be our supercell thunderstorms. Our supercell thunderstorms are most common in the mid-spring through the early summer. More often than not, they're going to be severe. They're going to produce your strongest tornadoes, your largest hail, and your most significant wind gusts. Now, within a supercell, there's two main types. Number one, you have your elevated supercell. Your elevated supercell is notorious for producing very large hail, but not tornadoes or damaging winds. The reason is, when we look at an elevated supercell and we look back at the ingredients for severe weather, an elevated supercell is going to have instability, it's going to have lift, and it's going to have wind shear. But what it's going to be lacking is that good quality low level moisture. Okay, so that storm is going to be slightly elevated in the cloud. So when we look at our cloud base heights, you want those cloud bases really low to the ground for tornadoes. So when you have those cloud bases slightly elevated, you have a stable layer near the surface. So as that supercell begins to form, or as that storm begins to form, you get horizontal rotation in that cloud. And as it takes on supercellular characteristics, that horizontal rotation then begins to spin vertically. Okay. Now you have your supercell with a mesocyclone, that persistently rotating updraft. Now with an elevated supercell, it's going to be very difficult for that rotation to then be stretched all the way down to the ground to produce a tornado. Okay. And we had examples of elevated supercells back several weeks ago. We had it, I believe it was April 4th. It was a Tuesday morning when very large hail traversed much of northern and central Illinois, where some of the hail size got up past baseball size. I was actually in your guys' neck of the woods just north of you, actually, where I got into some baseball size hail. And that was an elevated supercell. Now, if you remember that day, you remember that that morning, the temperatures were only in the mid 40s to around 50. Okay, not really conducive for significant tornadoes, but again, was notorious for producing very large hail because of the elevated nature. Now, a surface-based supercell, on the other hand, is going to have all four ingredients and it's going to have the right combination of those ingredients. I like to think about it like baking a cake because every cake has a recipe. And let's say that recipe calls for 4 cups of flour, 2 eggs, a cup of sugar, so on and so forth. And you decide to go add 7 cups of flour and 3 eggs and 6 cups of sugar. Your cake's probably not going to come out all that good. And severe weather is the exact same way. There are days where we can have all four ingredients present in the atmosphere for severe weather, but if we don't have the right combination, nothing's going to happen. That's why so often when you guys watch the news and the weatherman on TV, and he'll say there's going to be a severe weather outbreak across northern and central Illinois in 3 days. And you prepare for it, and then that third day comes, you get to about this time of night, and just like today, there's not a cloud in the sky. And all of us say, man, the weatherman got it wrong again. I wish I could get paid to be wrong 90% of the time and keep my job. See, I know how we all think. We all think like that. My parents still tell me that to this day. But the reason that happens sometimes is the weather models that we use to build our forecasts sometimes overestimate those ingredients, and the day comes and those ingredients don't happen and we don't get any severe weather. Now, we'd much rather have it happen that way versus the opposite of us not warning people and then have a significant event unfold. Now, this next image, it might be an image that a lot of you guys have seen before, specifically the left-hand image. Okay, it's your normal radar that you see on your phones, on TV. Okay, this is going to be a classic supercell. Okay, I'm hoping that you guys can see my cursor here. So we're going to look at 2 areas. This area between Tuscaloosa and Brookwood, okay, the core of the storm, and then this area back to the south and west. Now, think about which area of the storm is going to be worse. Is it going to be this area between Tuscaloosa and Brookwood, or this area down further to the south and west? Now, for those of you who think down in the south and west region is the worst part of that storm, you would be correct. That is where your tornado is going to be located. That's our hook echo. That's where that rotation is. Now, for those of you who maybe thought between Tuscaloosa and Brookwood, because you see all these really dark returns, okay, that was still a bad storm. In that area, that storm was producing at that time 80-mile-an-hour winds and baseball-sized hail. So if you're sitting in that area getting all that, and I tell you, hey, that's not the worst part of the storm, you're probably looking at me crazy like, what do you mean? That's not the worst part. But in fact, your tornado is going to be located back to the south and west side of that thunderstorm. Now, a lot of us believe that before a tornado impacts you, that everything will go eerily calm or go silent outside. The reason this happens, and it's not always the case, but in a classic example of a supercell, if this storm's moving southwest to northeast, and you're here just northwest of Brookwood getting all that heavy rain, hail, and high wind, as that storm moves northeast, you then get into this area right here, which there's nothing there. All you're going to have is a warm southerly or southeasterly wind and some lightning. There'll be nothing falling from the sky. But then as that continues northeast, that tornado then crosses into that area, and that's, of course, the worst part of that storm. So if you guys are ever in your safe spot during a tornado warning and you hear everything go silent outside, please stay in your safe spot for at least another 10 minutes. Make sure that storm has safely passed before coming back up. Or if you're like most of us Midwesterners and you get put under a tornado warning or you hear the sirens and you decide to go out to your front porch and look at it, if it goes silent outside and gets eerily calm, that's maybe your sign to head back inside because there very well may be a tornado located back to your south and west. Now, this image on the right-hand side might be an image you're not as familiar with seeing, okay? This red color is winds blowing away from the radar, so from left to right. The greens are blowing towards the radar, so from the right back to the left. So when you have that left to right and right to left motion and they're touching and you have high values, you know you have very strong rotation in place and a potential tornado in progress. Now, in fact, this was producing a high-end EF4 tornado through Tuscaloosa, Alabama during the super outbreak of 2011. Now, another example, and this one's not as clear-cut as the last one. We're going to start in this upper left-hand image. We see this reflectivity. We see this little hook right there, right? But it's not all that well defined. Okay, but as a meteorologist, you look at that, you're like, okay, especially if we know the background environment is supportive for severe weather, that piques our interest. So let's go over to velocity, the second image. Oh, now we see those reds and those greens popping up again and higher values than they're touching. Well, now we know we have some rotation within that storm. So now the National Weather Service would typically issue your baseline tornado warning. And that tornado warning would read, the National Weather Service is tracking a severe thunderstorm capable of producing a tornado located 5 miles southwest of LaSalle. Okay, we get put under several of those a year. And I can guarantee everybody listening does not take those 100% serious 100% of the time. But about 10 years ago, NOAA came out with dual polarization radar. Okay, what that means is the old radar used to scan the atmosphere horizontally. Dual pol now scans the atmosphere horizontally and vertically. So one really cool product that came out of that development was this bottom right-hand image. It's correlation coefficient. We're going to say CC. Okay, this product is able to detect debris within that tornado. Okay, so it's indicated by this blue area here. This is what we call the fallout. Okay, when that coincides with the rotation, coincides with that hook, now we know we have a tornado in progress, whether you can see that tornado or not. Okay, fun fact, this tornado happened at night on the leading edge of a squall line and was wrapped in rain. There was no way you were going to see that. But because now the radar is able to detect the debris within the tornado, knowing it's on the ground doing damage, now that warning is going to read, National Weather Service meteorologists are tracking a confirmed large and extremely dangerous tornado located 5 miles southwest of LaSalle. Now I can guarantee every single person listening is going to take that warning much more serious. Okay, so I can guarantee that this technology has saved hundreds, if not thousands of lives since it was implemented about 10 years ago. Now, when we look at the life cycle of a thunderstorm, every single thunderstorm on Earth goes through this process. On the left-hand side, we have our initial cumulus stage, our puffy white clouds on a warm summer day. All that is your warm, moist air rising up, condensing, and creating your cloud. Now, as that process continues, your cloud begins to grow taller. That updraft begins to grow stronger. Okay, at this point, it's still just a cloud. There's no precipitation falling down to the surface. Now, once that continues to grow and we start getting rain down at the surface, that's that blue arrow. That's that rain-cooled downdraft falling back down towards the surface. So you still have your warm, moist air rising up, feeding the storm. And now you have your rain-cooled air falling out and coming down to the surface. At that point, your thunderstorm is born. Process will continue. The storm will continue to grow stronger. And once it reaches its mature stage, at that point, that updraft and downdraft are going to be balanced within the storm and separated within the storm. So you have a steady feed of warm, moist air feeding it. You have a steady downdraft venting that thunderstorm. Okay, at this point, that storm will be producing the worst weather it's capable of, whether it's large hail, whether it's just heavy rain, damaging winds, tornadoes, etc. Now, we all know what goes up must come down at some point, and we reach our dissipating stage. When we reach our dissipating stage, that's when you choke off that warm, moist air, and this downdraft becomes completely downdraft driven, meaning there's no more fuel for that storm. It's just venting out all that rain-cooled air and starting to fall apart. Okay, just like us as humans, if we don't eat for a couple weeks, we're not going to survive. If you choke off the food for that thunderstorm can no longer survive. So this process from cumulus stage to dissipating stage can take 30 minutes. It can take 10 plus hours. Okay, it really just depends on the background environment from that day, on what the environment's conducive to do. Now, another view of a cloud, of a supercell. Okay, you have your warm, moist air rising up. We already mentioned that, your cool downdraft on the back end. But I want to bring your attention up to this 11-kilometer point in the atmosphere. This is the point at which thunderstorms can no longer grow vertically through the atmosphere. Okay, at this point, it begins to grow out horizontally and gives you that anvil appearance to the sky or to that cloud. Okay, but you may look at this illustration and be like, well, I see clouds up above that. Like, what is that? Well, up above that, that's what we call our overshooting top. When you have a storm that's explosively intensifying, sometimes it can be growing with so much vigor that it can actually briefly poke through that tropopause, that 11-kilometer point in the atmosphere, and give you that overshooting top appearance. Now, this is usually when you know that a thunderstorm is either rapidly intensifying or it's just an incredibly strong storm as it is. Now, at some point, that overshooting top will then settle back down to the tropopause and it continues spreading out horizontally. Now, the reason that thunderstorms can't typically grow above that point is because for clouds to continue to grow vertically through the atmosphere, you need the air mass to cool with height. Okay, so warmer at the surface and then cools off with height. But once you get above that tropopause, the atmosphere actually begins to warm back up. So it's not conducive for those storms to continue or those clouds to continue to grow vertically. Now, briefly, I'll run over the enhanced Fujita scale. It's the damage scale that was put in place to rate tornadoes based on the damage they cause, ranging from an EF0 being your weakest up to an EF5, your most destructive. EF0 and EF1 tornadoes account for 76% of all of our tornadoes. So the vast majority are going to be in this weaker category. Damage associated with them is typically pretty minor. Some tree damage, minor roof damage. Of course, trailers and mobile homes are never a good place, no matter the tornado. So it can cause significant damage to those. Now, once we reach EF2 and EF3, we start getting into much more substantial damage. Now we start getting into partial or roof loss, partial second story collapses, poorly built buildings ripped apart, cars tossed, things like that. Now, once you reach EF4 and EF5, those are upper end tornadoes that cause complete destruction. EF5 specifically are incredibly rare. There has not been a confirmed EF5 in the United States since Moore, Oklahoma back in 2013. So we have now gone just about 10 years without an EF5 in the United States. And the only EF5/F5 in Illinois, in the National Weather Service Chicago area was Plainfield back in 1990. Now, when you look at the tornado tracks, this is from 1950 up until 2017. You can see where the hot spot for tornadic activity is. Right through Will County, Kankakee County, extending west into Kendall, Grundy, and even LaSalle County. Okay, this is Illinois' tornado alley. Okay, right in that I-80 corridor, because warm fronts tend to set up along the I-80 corridor in the springtime, and tornadoes love warm fronts because you have better ingredients for severe weather, which set up along that front. It's a complete coincidence that it just happens to run along I-80. It's similar in the wintertime with the demarcation line between heavy snow and a mixed bag of precipitation and all rain. Typically sets up along the I-80 corridor. Now, knowing my story from earlier about Plainfield, you'll know that I live in that Plainfield and Joliet area. So I have had my fair share of tornadic activity and close calls at my house. In my lifetime, I've been impacted twice by tornadoes at my house. One was in 2003 and one was in 2004. Both were weaker. One was an EF0, one was an EF1. So I played right into that statistical average to be hit by tornadoes. Now, a little bit about the Storm Prediction Center. Storm Prediction Center out of Norman, Oklahoma issues convective outlooks every day, ranging from a level 1 marginal risk up to a level 5 high risk. Marginal risks are for your run-of-the-mill isolated severe storms. Okay, we get put under several dozen of these a year. Nothing all that significant, just again, run-of-the-mill. Slight risks, still run-of-the-mill, with just a little bit higher coverage area. We get put under probably a couple dozen of those a year. Enhanced risk, we start getting into more substantial severe weather. We get put under probably 3 or 4 enhanced a year. Moderate, we average once a year. That's reserved for your severe weather outbreaks. And a high risk is once every 2 to 3 years, reserved for your very high-end damaging wind events or your tornado outbreaks. Fun fact, though, state of Illinois, we've already had 1 high risk and 1 moderate risk for the year. So we have reached our quota, therefore no more storms for the year. I know those of you who don't like storms will probably love that, but that is not realistic. We'll probably get active again probably towards, I'd say, early June. The rest of May looks relatively quiet, at least for large-scale outbreaks across our part of the country. Now, moving on to a couple high-impact events. Number 1, November 17th of 2013. This was the Washington EF4 tornado, which I'm sure you guys are very familiar with. This tornado was part of a very large outbreak across the Great Lakes region. The red area on the map is the moderate risk issued by the Storm Prediction Center. The red or the purple and pink area, that's your level 5 high risk. A couple things to note with this. Number one, the area of the country this is in for the time of year. Exceptionally rare to get this kind of risk level in this part of the country a week before Thanksgiving. Number two, the sheer size of this risk area. The normal high risk might be the size of, let's say, northern Indiana. Okay, you can see how just massive this high risk is. Okay, truly exceptional setup. And then all the tornado tracks are listed through here, and you can see the prime spot for tornadic activity was actually through Indiana. But everybody remembers this outbreak for Washington, because Washington was the strongest tornado of the day, packing winds estimated at 200 miles an hour. Mind you, an EF5 starts at 201 miles an hour. Now we look at the satellite images from this day. First image on the left is taken the day after. You can clearly see where that tornado crossed. Okay, these damage scars can last on satellite for several years. Okay, this image on the right is a zoomed in view. You can see just the complete destruction throughout this neighborhood in Washington. Now, one thing I want to point out with this picture, specifically the one on the left-hand side, if you guys can see these little swirl marks in here. Okay, these swirl marks are actually sub-vortices. They're smaller vortices that rotate within and around the parent tornado. So to give you perspective, this tornadic damage path was from the very top of this photo all the way down to the very bottom of this photo. But you can see how small those little sub-vortices are. Okay, these are what caused the extreme damage. These are the ones that have been estimated to contain winds of 2 to 3 times the amount of the actual tornado. Okay, that's why it gives the illusion as a tornado is crossing through a neighborhood. Okay, and after it goes through, it may look like one house is completely leveled, while the next house right next door looks relatively untouched. And people always think, man, that tornado must have skipped through the neighborhood, when in reality, it didn't skip. In reality, what happened is that house that was completely destroyed got hit by one of these little sub-vortices. Okay, so again, these are typically very, very small, and around the base of it, you can see that deep ground scouring right at the base. Because as these rotate around, they tend to hit the same area. And even if you track this back to the south and west, you can see the complete destruction through here and the much more minor damage over to the right. Now, this image on the left is a zoomed out view. Okay, the tornado was on the ground for a very long time, over 60 miles on the ground continuous path through Washington up into rural LaSalle County. Now, on the right-hand image, this was taken 6 months after. Once again, you can clearly see exactly where that tornado crossed through. Now, looking at radar from this day, okay, I want you to pay attention to the time. This initial tornado touched down southwest of Washington at 10:59 in the morning. People are just getting out of church. People that were at home are getting ready to watch the Bears play in Chicago. Okay, and we have a tornado touching down a week before Thanksgiving. Now, by 11:12, 13 minutes later, that tornado reached peak intensity just northeast of Washington. Okay, took 13 minutes for this tornado from initially touching down to then producing high-end EF4 damage. Incredibly rapidly intensifying tornado. Okay, and when we talk about the CC earlier, the correlation coefficient, and mentioning how that detects debris, when you have a violent tornado, the actual radar can detect that debris. When you see that purple area in that hook, you know that's what we call a tornado debris signature, TDS. That's when you know that tornado is causing significant damage through that town. So again, if you see that on radar coming towards you, that is a bad sign. That means a very significant tornado is heading right for you. Now, another event to look back on is April 9th of 2015. This was the Rochelle and Fairdale EF4 tornado. This was part of a local outbreak which had 11 tornadoes, 6 of which from this one storm. And this was the strongest tornado in the National Weather Service Chicago market since Plainfield in 1990, and still is, coming in at high-end EF4 again, once again with estimated winds of 200 miles an hour. Again, EF5 starts at 201 miles an hour. So catching my drift about the fact there's been no confirmed EF5 since 2013. I firmly believe there have been plenty of EF5 since. They just have not been rated as such. And that's a whole nother discussion, which if someone has a question on that, I can answer that at the end. Now, when we look at the surface map from this day, I mentioned earlier that warm fronts and tornadoes get along really well. Okay, reason is, so we look at the synoptic pattern, okay? Our low pressure system centered around the Quad Cities. Warm front draped off to the east, our cold front trailing back to the south and west. These red numbers are temperatures, the green numbers are dew points, okay, the measure of moisture in the air. So we go north of this warm front, we see temperatures in the 50s, dew points in the 50s, okay? Not conducive for severe weather, specifically tornadoes. And the winds are coming out of the east. Whoops, I'm sorry, wrong way. And the tornadoes are coming out of the east. Or the winds, are coming out of the east. So these wind barbs, that's the direction of travel of that wind. Okay, so temperatures in the 50s, dew points in the 50s, winds out of the east. Not conducive for tornadoes. We look back behind this cold front. Okay, temperatures are quickly falling through the 70s down to the 60s, 50s, and even 40s through central Iowa. Dew points again in the 40s. Not conducive for severe weather. But then we're going to look east of this cold front and south of this warm front, in this what we call open warm sector. This is where all your warm, moist, unstable air resides. Okay, we have temperatures in the mid 70s, dew points in the mid 60s. Now, you notice how the winds are coming out of the south as well. Okay, good orientation for quality wind shear. Okay, because you have the upper level winds out of the west, you have surface winds out of the south. So you have almost that 90-degree turning through the atmosphere. But up along this warm front, you get the moisture to pool slightly. So your moisture actually increases. So down here where dew points are in the mid 60s, dew points actually pool into the upper 60s along this warm front, therefore increasing instability and your thermodynamic environment. Also along that warm front, the winds will back out of the south and east slightly. So you have upper level winds out of the west, you have surface winds out of the southeast, you have extra turning through the atmosphere. Okay, that little bit extra push of wind shear and thermodynamic energy is what takes that storm from producing your run-of-the-mill severe weather to producing violent tornadoes. Okay, so as those storms move up, they interact with that warm front, latch onto it, will typically take a right turn, meaning they'll start heading more easterly rather than northeasterly, and produce your significant tornadoes. So when this tornado touched down, it touched down at 6:39 in the evening north of Franklin Grove, causing relatively minor damage on par with EF0 to EF1. Okay, minor damage to that industrial building, a little bit of damage to that farm. By 7:02, that tornado has reached peak intensity. Okay, the view of the tornado was incredible. Seeing that kind of structure is that upper right-hand image. Seeing that kind of structure from a tornado in northern Illinois in early April is quite rare. Now, this was not my picture. This was Walker Ashley's photo. But yeah, beautiful, beautiful tornado from a photography standpoint. Now, if anybody knows knows about vehicles, you probably know that vehicle on the bottom right-hand side is a smart car. For those of you who are not familiar with smart car or don't remember smart cars, they were those tiny looking little clown cars that you feel like nobody can fit in. Everybody made fun of them, but I will say, when cars go through an EF4 tornado, typically they are unrecognizable. For those of you who know that's a smart car, you can still see that's a smart car. So I always say if smart car was smart, they would have run a promotion on this or a promo saying, hey, look, my vehicle got thrown through a high-end EF4 tornado, and you can still tell what kind of vehicle it is. But unfortunately, they weren't smart, hence why they're no longer around. I'm going to say that is the reason they're not around, even though knowing that is, of course, not the reason. Now, by 7:13, that tornado crosses I-39, moves into Fairdale. At this point, this tornado makes its most significant impact, destroying the vast majority of this little town. Now, there's a video on YouTube, and I don't put it in this presentation for the reason that it can be very graphic. Okay, if you guys want to watch it afterwards, you're more than welcome. Just type in YouTube, Fairdale, Illinois tornado. It'll be one of the first search results. But this gentleman was filming this tornado from his second story in Fairdale. His wife was down on the first floor. He made the mistake of thinking that the tornado was going to miss town. What he failed to realize was if a tornado does not have left to right or right to left motion, it means it's heading right for you. and the tornado is heading right for his house. Tornado comes into his neighborhood, is destroying these houses, and he's not moving. He's holding firm on that second story, filming it. And the video is a great video to see how chaotic it is during a violent tornado. Because as it nears his house, you see the houses across the street literally just exploding. Okay, you see the power lines coming down, the trees coming down, just very chaotic. And then it hits his house. You hear his house just implode. And he was taken from his house and found in a field. He was found alive. But his wife on the first story did not survive this tornado. She passed away. And tragic, absolutely. And this is why we need to be underground during these tornadoes. This is why we don't want to take these tornadoes for granted. The likelihood of getting hit by one of these is incredibly rare, but there's always that potential. So don't wait until this happens to then be prepared after. So again, if you guys want to see the video, you're more than welcome to, but I don't put it into the presentation for that reason. Now, when we look at our models, our mid and long range models specifically, okay, these give you a very coarse overview of the overall synoptic pattern in the long range. Okay, I typically use three models: the ECMWF, which is the European, the GEM, which is the Canadian, and the GFS, which is the American model. These run at a resolution of 9 to 12 kilometers, which, as I said, will just give you a coarse overview of the overall environment. Now, these run out far in advance. The GFS 384 hours, the GEM and the European 240 hours. Okay, so I always tell people anything beyond several days out, especially specifics about, oh, Northern Illinois, you're getting a tornado outbreak in 5 days. There's no way we can confidently say that far out. What we can say, however, is parts of Illinois and the region are under the gun for a potential severe weather event in 5 days. We can start highlighting the potential for some inclement weather, but to get down to the specifics that far out we don't have that skill level yet. Okay, because these models tend to overdo these setups. They tend to, in the long range, make it look like it's going to be this massive setup, and then the day happens and it underperforms. Okay, so never ever take if someone goes and tells you we're getting a historic outbreak or a historic snowstorm or anything historic more than a couple days out, please throw it away. There's no reliability with that. Now, when we look at our short range models, we call them our convective allowing models. Typically use the HRRR, NAM 3 kilometer, and the RAP. These are going to run at a much finer resolution of 1 to 3 kilometers, meaning it's going to model individual storms. It's going to give you a much better idea of the overall sensible weather that we're going to be feeling. Okay, much more specific, much more detailed. So in theory, these should be much more accurate because they're much shorter range. The HRRR runs out 18 hours. The NAMs run out about 60 hours, and the RAP about 50 plus hours. So you think these are much shorter range, they can be much more accurate. That's not always the case, though. There's sometimes when these models nail a forecast. There's sometimes when they completely fail on a forecast. And when these models are very divergent as we near an event, we then start turning to surface observations, the observed data from the weather balloon network across the country. Okay, those weather balloons go up several times a day, all across the country, and we can see that data. So then when we look at that data, we can start looking at the models and the data and seeing what model has the best handle on the near-term environment and start building our forecast from there. That's why forecasts between outlets are always going to be a little bit different, because everybody interprets this data a little bit differently, and everybody has their favorite models that they like to use. So that variability is actually very good. That tells you that these forecasters are putting in the effort to build their own forecast based on their knowledge of the area and their knowledge of the observed data. Now, when I show this picture, I always like to ask people, how many of you guys rely on tornado sirens for your warning? Okay. Now, if you're one of those who rely on those tornado sirens for your warning, what if I was to tell you no sirens are going off when I took this photo? This was the Sycamore, Illinois tornado back in August of 2021. This tornado developed incredibly fast, went from being a wall cloud up at about this level to then stretching, producing a tornado and destroying this home in about 30 seconds. Okay, and fun fact, I've been doing a lot of these programs over the past couple months, but I had two programs this or end of last week. One was in Sycamore. I was at a school, and I showed this picture, and the student raised his hand and said that was my house. So I took a picture of his house and his farm getting destroyed. And I asked him the question, were the sirens going off? He said no. And then the next day, I at another school in the area, and there's a teacher who was later impacted by this tornado just down the road that got destroyed. And the thing I always like to say, okay, tornado sirens were implemented back in the 1950s. Okay, we are in 2023. So to rely on technology from the 1950s to keep us safe today is absurd. Okay, nowadays we have internet, we have phones, we have TV, media, social media. I mean, you name it, we have it. So to rely on technology back from the 1950s is crazy. Now, I'm not saying completely ignore the tornado sirens, but it should never be your go-to way to receive that warning. Now, this is usually when I do my interactive portion, but us being virtual, we'll play it a little bit differently. So for a storm to be considered severe, I always like to ask, how fast do the wind speeds have to be? And you can think about it. How fast do those winds have to be? Okay. The other one, how big does the hail have to be? Answer for the first one, for damaging winds in excess of 60 miles an hour is considered severe. Well, technically, I should say it's 58 miles an hour. Why they didn't just round it up to 60, I'll never know. But 58 miles an hour is the technical term, but we're going to go and round that up to 60. For hail size, quarter size and above is considered severe. So 1 inch in diameter. It used to be nickel-sized hail, and then they realized nickel-sized hail doesn't cause damage, and moved up to that quarter size. Now, the sun is still shining outside, yet you hear thunder. You should always seek shelter. I know what we actually do. Okay, I know that when we hear thunder, if we're outside, we typically look around and we shrug our shoulders and we go back to what we're doing. But when you hear thunder, you're close enough to be struck by lightning. Take it from me, who's almost been struck by lightning twice in my chasing career. It's not fun. I really don't recommend it. The first time was my first time chasing outside the state of Illinois, and I was down in Missouri filming the storm. Storm's getting closer, lightning's getting closer. I had that thought of like, maybe I should go back to my car. I'm like, nah, I'm good. And I look over at my car, and I remember that I had a 3-foot antenna off the back of my car for a CB radio. And I look at it, and I'm like, maybe I should go take that 3-foot lightning rod off the back of my car. So I go over there and I grab it. And as soon as I grab it, I start getting shocked. I'm like, all right, that's not supposed to feel like that. So I take it off, I throw it in the back of the car, and soon thereafter, lightning struck a power pole right next to me. So I'm like, all right, I've learned my lesson, right? Wrong. 2 years later, did the same exact thing, okay? This time I was standing on a big open field where I was the tallest object. Now, we all know what they say about being the tallest object during a lightning storm. Don't be. So I ignored it again, and then I felt my hair on my arm and my neck go up. And I remember when I was little, and my mom used to say, if you feel that electricity during a lightning storm, run. So I did. Ran back to my car, and sure enough, maybe a minute later, lightning struck another power pole. So now I'm like, hey, now I think I've learned my lesson. Done this twice, let's never do this again. Okay, and so far I have not done it again. I've stuck at 2, and I'm content staying at 2 times. Now, after that storm passes by and you hear that last rumble of thunder, you should wait 30 minutes before resuming outdoor activities. Same reason as before, you're still close enough to be struck by lightning if you don't wait that 30 minutes. But again, I know what we actually do here in the Midwest, and as soon as that rain stops falling, we're usually back outside. Now we look at hail size. Anything we already mentioned above a quarter size is considered severe. The biggest hail I have personally seen is between softball and grapefruit size, so 4.25 inches in diameter. Okay, when hail gets that big, it makes a very different noise when it impacts your vehicle. Okay, Now, this photo, this was not the biggest hail I've ever seen in my life, but it was still very large hail. Mainly baseball size. This one was a little bit bigger than baseball. Okay, story behind this. I mentioned earlier that I guide tours with Tornadic Expeditions. So we were on a tour, tour 4, and we had some COVID cancellations from years past. So we had to book some extra people. So the tour director owns 2 vans, but with 12 guests, we had to rent a 3rd van. So I got put in charge of getting the rental. I get down to Oklahoma City and I go to the rental car place, fill out all the paperwork. Lady tells me you can pick out any minivan in the lot you want. All right, cool. Let's go. So I go out there. Every single minivan in that lot was a top of the line minivan, brand new, with that dual pane sunroof, so that complete glass roof. And I'm sitting there, I'm like, we're going chasing for 10 days. I can't have a glass roof. So I walk back inside and I'm like, hey, do you have a more basic minivan? And the lady gave me the weirdest look ever. Because when we get rental cars, normally you want the best vehicle you can get for your money. And here I am asking, like, hey, do you have like a crappy vehicle around the back that I can use instead? But she looks at me and she's like, no, what we have is what we have. Like, all right, fair enough. So we get this minivan. Okay, it's this red one over my shoulder. Brand new, had 400 miles on it, still smelled like new car. So we start chasing. We get all the way to day 6 with no issues. But then day 6 happens. Okay, we get on this storm in South Texas, and we knew it was producing hail, but we assumed the hail was pretty small, on the order of maybe dime to penny size. So hail starts falling, it's making these pinging noises. The guests love it because it's exciting, it's loud, it's fun. But these pinging noises start turning to thuds. Now we're starting to have ping pong ball to golf ball size hail falling from the sky. And I'm like, oh no, we gotta go. So we get through the storm. Okay, everybody gets out, they're taking pictures, doing what they need to do. But then they start walking around to the front of my van and they start pointing at the hood at all these new dents in this van. And I'm like, great. Like now the rental's all dented up. But it is what it is. We gotta keep on the chase. So we get back on the chase onto the storm. Well, now it's producing the hail that you see on the right hand side. Okay. When hail gets that big, it tends to start bouncing. So now this hail is hitting the pavement and bouncing up and over our vehicles. I said some words I won't repeat in here. And I'm like, no, like we got to turn around. If I take one of these hailstones to the roof of this car, I'm going to lose that glass on the roof and it's going to be a bad time. So I radio to the other 2 vans. I'm like, hey guys, we got to turn around. So we go and we turn around. The white van over my other shoulder, the one the tour director owns, takes one of these hailstones off the roof of his car and left a massive crater in it. I saw that happen right in front of my eyes because I was the trail van. I was van number 3. And I said some more words I won't repeat. I'm like, we have to go. So we are flying out from the storm. Okay, we get through without any other incidents. We continue chasing and have a successful rest of the tour. But then day 10 comes. Now I have to go return this vehicle. So I get back to Oklahoma City and I'm sweating because I'm like, man, what is this lady going to say? I took this van out, brand new, 400 miles. I am now returning it with over 5,000 miles on it, all dented up and with a cracked windshield. Mind you, the windshield cracked was not from me, it was from a rock off of a semi. So it wasn't all my fault. I'm like, what's she going to say? So I pull into the lot, I get out. She hops in the driver's seat, she writes down the mileage. And all she does is she just looks at me and she's just like, all right, you're good to go. I have never been more relieved in my life because normally, like in our part of the country, we don't typically get hail that size. I know this year has been a little bit different in that regard, but on a typical year, we don't. So if we cause that kind of damage up here, there'd probably be some questions to answer. But down in that part of the country, in Texas and Oklahoma, they're so prone to really large hail events that almost every vehicle down there is dented up as it is. So for her, she probably saw that and was like, man, they had some fun over the past few days with that hail. But thankfully now the tour director has bought a 3rd van, so we will no longer be renting vehicles. Now, a couple common tornado myths that I still hear today is that tornadoes can't cross rivers or bodies of water, or they don't happen at night, or hit the same place more than once, or hit big cities, so on and so forth. Every one of these on this screen is false. And it gets proven false year after year, yet people still tend to believe them. Okay. Coal City was hit twice in 16 months. Okay, so hit the same place more than once there in the matter of a year, less than a year and a half. Nashville, Tennessee was hit back in 2020 and debunked all of these myths on the screen from that one tornado. So never believe that can't happen to you, because there's always that potential. But a bit low, there's always that chance. Okay. Now, storm chasing. All storm chasing is the act of going out of your way to pursue a storm. If you leave your house to go storm chasing or to see a storm, technically you're storm chasing. But just because everybody can storm chase, I always say not everybody should. At the end of the day, it could be an incredibly dangerous hobby where you put yourself or others in a lot of danger. Myself included. My first time chasing outside the state of Illinois, which coincidentally was the same time I was almost struck by lightning for the first time. I was also almost hit by a rain-wrapped EF2 tornado, because I was with a buddy who had as much experience as me at the time, which was 0. And we were chasing this tornado wrapped in rain. And it was just to the west of me. We were driving north on a road, just to the west of me. I knew it was to the west of me and coming towards me, but we couldn't see it. And I was in all the heavy rain, hail, and high winds, and I couldn't see the road. My buddy kept telling me, dude, you have to keep going. Like, if you don't keep going, we're going to get hit by this tornado. And I got to the point where I couldn't see over the hood of my vehicle anymore. And I told him, I'm like, I have to stop. I can't drive if I can't see. And that decision for me to stop potentially saved me from getting hit by this strong tornado, because not 200 yards in front of me, there was a house that got destroyed. And I would have driven right into that tornado and never known. So after that point, I teamed up with Adam Lucio, who's one of the most well-known chasers in the country. And he taught me everything he knows about chasing and became my chasing partner. So he taught me how to do it the right way and to stay safe while doing it. Now, a few photos I want to show you guys. This first photo you're probably looking at and you're like, well, what am I looking at? I see a bunch of random people standing on the side of the road. Well, that is what we are looking at. We are looking at a very large tornado down in Morton, Texas last May. The reason it looks like this is that part of Texas is under an extreme drought. Okay, so we had 70-mile-an-hour winds blowing into that circulation. So it's kicking up all that dust, okay, and ingesting it into that circulation, which made it very difficult to see. Now, a picture that's not difficult to see is this supercell over the northern high plains. This whole area here is rotating. This is what we call our mesocyclone, our rotating updraft. No tornado yet, but just that mesocyclone. Okay, there was a funnel that was starting to develop here that later produced a tornado about 30 minutes after this photo was taken. Now, after that Morton, Texas tornado, this was the sky that was left behind. Okay, we call it a mothership supercell, where it looks like a spaceship. You see these different levels going all the way up that updraft. Truly a remarkable sight to see in person. And in 2014, Pilgrim, Nebraska, one of the more infamous tornadoes in our country's history. 2 violent EF4 tornadoes ongoing at the same time from the same storm. No other time in documented history has this occurred. And funny story is, I had the chance to chase this day. Adam texted me the night before. He said, hey, man, you want to go chasing tomorrow? And at that time, I was 20 years old, and I decided, no, I'm going to be a responsible adult. So I told him, no, I'm going to go to my regular job. Oh, man, that decision right there for me to be a responsible adult cost me the opportunity to see one of the most historic tornadoes in our country's history. Mind you, for a job that I no longer have. So to say I am bitter about this photo is a gross understatement, but it does show how much I want all of you guys to see this photo. Then next up is Dodge City, Kansas, back in 2016. Probably one of the more photogenic tornadoes that have happened in recent memory. Over open land, not doing any damage to structures, which is the best case from a chasing perspective. And this tornado was on the ground for nearly an hour. And after Dodge City passed, this was the sky that was left behind. See that rainbow on the bottom left, and you see the sun rays through the center of the screen. Truly a remarkable sight. And it's something that keeps you coming back for more, because every storm and the aftermath of that storm always has a slightly different sky and something to kind of keep you coming back. To photograph this stuff is absolutely incredible. And then one of my favorite things to photograph, yet the thing I'm still most fearful of, because tornadoes, I know where they're at. Large hail, I know where it's at. Lightning, I don't have a clue when or where it's going to strike. Now, the last photo was this Washington tornado as it passed through Washington. This was taken by Adam outside of Roanoke. Thing about this tornado is that I live 120 miles from Washington. And on this day, I found people's belongings from Washington in my yard, 120 miles away. Found letters, found photos, and I found dry cleaning slips. And I'll never forget the letter that I found. It looked like it had just come off their kitchen table. Just some water on it, no mud, no dirt. And I went to Google and I typed in that address and I hit Street View. And I knew in that moment that house I was looking at on my computer screen was no longer there. And I knew that because I had their belongings in my yard 120 miles away. So for me, it put a whole new perspective on storm chasing and weather for me. It gave me a new purpose as to why I chase, for more of the public safety aspect. How can I report these storms to the National Weather Service to help the warning process? How can I report what I'm seeing to keep people, do my part to keep people safe? So that's when my whole kind of mindset with weather changed a little bit. Now, I do have one video to show you guys. This video is going to show you what very large hail does to your vehicle. And then after that, we'll take, I see there's some questions in the chat box. Sorry for the buffering video on that one. I know virtually sometimes it doesn't come through, but you get the gist of what very large hail does to your windshield. That was baseball-sized hail. Hence why most people do not want to drive in that sort of hail, because it will destroy your windshield and create massive dents in your car. Now, with that being said, I'm going to go ahead and look in the chat box, see what kind of questions we have. All right. All right. I see a lot of where you're from. Madison, Wisconsin. Awesome. Ottawa, Lafayette, Colorado. Madison, Omaha, Nebraska. Oh, you're living in Texas. Henry, Illinois. So there's people from everywhere. Cool. So Philadelphia. If you guys have any questions, feel free to put them in the chat box before we wrap up.
I have a few. I have a few for you.
Absolutely.
Okay. Nick, I have actually three things to ask you. You said to anyone who was interested in the EF5 tornado, you were going to talk more about that later if anybody was interested, and I think several of us might be. I also wanted to ask you, how actually do you chase a tornado? Do you go parallel in front of it? Do you go parallel beside it? How does that work?
Good question. So I'll do the how do I chase a tornado first, and then I'll get into the EF5. So in terms of chasing a tornado, if the tornado is typically moving southwest to northeast, and I'm on a gridded road network, so like central Illinois is fantastic for that. North to south, east to west roads everywhere. So if the storm is moving southwest to northeast, I will play to the southeast side of that tornado and just stair step northeast with that storm. That way I get a very good view of that tornado. Even if I can position myself just to the northeast of that tornado and adjust where need be, that can sometimes give you a really cool contrast to the tornado with the sky behind it. That usually gives you the best viewing, is also one of the safest spots to be. There's people who come in from like the west. Problem with that is then you're fighting through precipitation. The tornado is going to look very low contrast and not be good for photos. And then if you're directly north of it, you're putting yourself precariously close to that hail core. And also, if that tornado starts to occlude and starts to weaken, it will typically take a hard northwest turn, and that could put you in some danger. So I like to stay on the south east side of that circulation as it's moving northeast. And then with the EF5, so my belief is there have been plenty of EF5 since 2013. However, when the National Weather Service, and specifically the structural engineers who come out for the violent tornadoes, the EF4 plus tornadoes, they have very specific damage indicators to rate their tornadoes. And one of the damage indicators for an EF5 is for a well-built home to be completely swept off of its foundation. But the extra part of that is that well-built home had to have had anchor bolts in the foundation. Okay, the vast majority of homes do not have anchor bolts in the foundation. So you can have, even if it's the most violent tornado this earth has ever seen, if what it hit did not have anchor bolts, it cannot get an EF5 rating. So it's an incredibly flawed system. I believe Washington was an EF5. I believe Fairdale was an EF5. Mayfield, Kentucky was an EF5. I mean, I can go on and on. However, because they didn't hit anything that matches that high-end damage indicator, they can only cap it at an EF4. So that rating system is in the process of being updated to hopefully alleviate some of that. But that's something that we have to still deal with for a couple more years.
Wow, thank you. That really is interesting to hear about how it really is antiquated to look at it that way. Looks like you have some questions in the chat now.
All right, so let me see where we're at. Okay, so how would you explain this weather and how to be prepared for someone who is not from Tornado Alley? Good question. So for that, best thing to do if you're living here now with tornadoes, safety plan wise, I always recommend knowing exactly where you need to go in the event of a tornado. So at home, whether it be your basement, an interior room without windows, what documents and what stuff that you would normally bring to your safe spot in a situation like that, have that stuff ready. That way, in the event you're under a tornado warning or there is a tornado heading towards you, you can literally just grab it and go to your safe spot. So basically, the advanced planning is really important. Number two, having a weather radio inside your house. They're like $35 on Amazon or at Walgreens, Midland weather radios. They have battery backups in case your power goes out. The alert tone is very annoying and very loud, and it will wake you up when you're sleeping, which is great for nighttime events. I always tell people that you don't live in a house without smoke alarms. So why would you live in a house without a weather radio? So those are the two key things I always tell people. Have that safety plan, know where you're gonna go, have that everything you need to get to your safe spot so you're not scrambling around the house as the sirens are blaring, and have that weather radio. Those are the main things I would recommend. And then if you're out and about, you know, if you're on an open road with nowhere to go and there's a tornado barreling down on you, best thing to do is get out of your vehicle and lay in a ditch. Don't go under an overpass. Laying in a ditch is going to be your best option. However, still not a great option. Don't get me wrong. I'm not saying next time go seek out a tornado and go lay in a ditch and test it out. Don't do that. But that's your best thing to do if you're stuck with zero options. All right. So next question. So what are your thoughts about the rating system for tornadoes, since it's just based on wind damage reports? Who has the ability to change this criteria? So National Weather Service is in the process of revamping the EF scale to now include Doppler estimated wind speeds, because our Doppler radars have gotten good enough to get a good estimation on those winds. A great example of it is the El Reno, Oklahoma tornado back in 2013. Doppler on wheels measured 302-mile-an-hour winds with it, and it initially got the classification of an EF5, but it was downgraded to an EF3 because it did not hit anything that required an EF5 rating. So they are going to start now allowing those measured wind speeds to be implemented into that rating, which should help alleviate some of these issues. Where else in the world gets tornadoes like we do? Australia gets them in our winter time. That's their summertime. They get tornadoes down there. Italy, basically any of the Middle Europe or European countries do get tornadoes. However, the U.S., central U.S. is the by far the peak area for tornadic activity. Central U.S. is number one in the world in terms of the amount of tornadoes and the intensity of those tornadoes. Even China and Japan get tornadoes as well. All right. I think that's all the questions I see in the chat box currently. So
Okay. I can see that after the fourth time we just stayed up, I'm sure that related to the weather radio. Yeah,
yes.
everybody just stays up.
Now, I will say with one thing with the weather radio, you can customize it because they will blare and go off for a flash flood warning, which for a lot of us, we don't need to be woken up in the middle of the night for a flash flood warning unless you live in a really low-lying area. So you can actually set it to not tone during that event, because I've been woken up for a flash flood warning when I'm in no danger of floating away. And yeah, it's not a good feeling when you gotta get up in the morning and the weather radio goes off at 2 a.m. for a flash flood warning. So you can adjust that as well.
Let's see, I tried to figure that out, but I just ended up making it tone for everything.
Yeah, I would just go to YouTube and type in how to program your weather radio. It can be tricky, especially depending on what weather radio you do have. So I would just go to YouTube and search it, and it should have a tutorial on exactly how to do that.
Okay, if anyone else has a question after we conclude tonight, just send it in to Rachel and we will make sure that Nick gets it. Can I do that, Nick, and have you respond to the person then?
Oh, absolutely.
All righty. Well, thank you to our audience for attending, and I hope you've enjoyed the program. It certainly has been insightful, and the photography is quite scary and impressive at the same time. Please, for our audience, to complete the short pop-up survey that will appear when we do close the Zoom connection. And now, Nick, I'll turn it back over to you for closing comments.
Yeah, so I just want to thank all of you guys for tuning in tonight. I know you have a choice on what you do on a nightly basis, so I'm very appreciative that you decided to join this program. Hope you're able to learn something. I hope you guys have a great rest of your evening. And yeah, thank you guys very much.
Thanks, Nick. Very much appreciated. And thanks to everyone. Until next time, good night.